What's going on, everybody? I know it has been a long time since I have put any kind of content up on this channel. I don't know, maybe I changed that a little bit. I want to give a shout out to my friends at Chase and Rust, Randy and Josh McCauley. They kind of called me out on it. and I figured I'd record something different here. Something not a lot of people know about, how they operate. We got this Pickering governor here. It's actually off of our Minneapolis steam engine. We also got this hydrostatic lubricator that is also off of our engine. Lots gone on with that engine the last few years. Not going to get into that in this video, but she is running and driving. We do a few projects every year on it, hoping to get our water tanks done to be put on it this year. Working on some roof brackets. Would like to get a roof on it before our show in September, and we'll see what happens. So last year we had this belted up to a rock crusher, and a 28 Minneapolis should not have any issue running that rock crusher. I mean, there was a little, I think it's 17 horse Harrison Jumbo that ran that thing just fine, and the governor was having issues. First time since we've been running it that it's had issues. We've never had this thing apart, cleaned it, made sure everything was good. So that's kind of what I decided to do this winter. Keep in mind, I have never dug into one of these governors. Super simple. There's another gentleman on here, if you search up Pickering governor disassembly, he walks you through how to disassemble one, how they work. I'm going to give you my very basic representation of how these work, and we'll go from there. So this is a later style Pickering governor. Of course, our engine is a 1920 Minneapolis. I've heard Pickerings are pretty popular. I'm not as familiar with Gardners, but the Gardner governors that I've seen, they use more of like a flyweight on a pivot than what these do. These actually use spring steel on these. But again, I've not been around very many Gardner governors. Essentially, as these fly apart, okay, you see this main central shaft here. This is stationary. This is actually a part of your main housing here. It goes down in here and is stationary. But there's a central shaft running through the middle of it, which you will see poke through kind of right down here. Okay, so that is actually what this is acting on. There's a screw with a hole up here. You put oil in. It oils this top bearing. The oil kind of comes down. You've also got a little oil cup here you oil. That kind of, it has a little slot in here to actually oil this lower bearing and all that. I did have to put a shim in it to get these gears to mesh a little better, but it looks like it's meshing a lot better now. Thing was caked in oil and grease. I'm not going to get a very good angle of it here, but this kind of area right here where this fork and where it kind of moves, your ball ranger, your speed changer there, moved. It was all kind of gunked up, so hopefully cleaning it's going to really help it. This shaft, this is your second shaft, so this is actually a two-piece design. You got your first top shaft here, you got your second shaft here, which actually goes through your packing and is actually what controls your valve. This is a balanced type valve whenever it's in its housing, which I don't have the housing here, it's still on the engine, but you can also see it is a rant design, so as this starts to open and shut, it is opening and shutting it gradually, not all on or all off. Okay. Your speed changer, it's going to be a bad angle here. Also called your ball ranger. I'm going to flip this over. And I had a good example of how it works here. But this goes, screws in and out. Okay. If you look real carefully, I don't know if I'm going to get it or not. I'm going to screw it in. You can see it's extending the shaft, and then as I come out here, you're shortening the shaft. You're basically extending or shortening the overall length of that shaft in the middle, and that's what will affect your overall top speed. These governors only work whenever they are at full load, top speed, not while you're just kind of putzing around. And I want to say this one is rated. There's a rating on each of these. The earlier ones didn't have that speed changer on them. Oh, excuse me. They were basically just set at a certain speed, and then you were set at that. So guys would have to go through and actually grind or change effectively the length of their shaft if they wanted to kind of change the speed, but then you were kind of set at that. 300 RPM, shaft revolutions. Okay. But you got that, and a lot of the later Pickerings had that. Then you got this doodad here called your Sawyer's handle. How that basically worked is if you were on a sawmill or any other stationary belt work, if you were going to be pausing for a while or needed to slow down temporarily, you'd have a rope or a chain or something attached to this to the guys there running the sawmill. I'm going to have to press on this because this is under constant tension. And what happens is there's a fork here, okay? And so, of course, pretend I'm pulling on it. Oh, bad angle. But as I press on that, it will push this down, which will push this down inside the housing, causing it to shut. Okay, so I don't think it shuts it all the way down, but it definitely lowers it. And then when you're ready to go, they let go. Spring tension kicks it back open. Now you're ready to go again. Okay, in an emergency setting, that's real handy. I've seen some of these, and it was optional, though I have heard a lot of traction engines did not have it. There's a feature that could be bolted in here, and it rides on your belt. It's a secondary pulley. So as you're going along, and say your belt breaks, okay, it causes a trip. It's another arm. It comes down. It'll slam shut. Hits this kick arm right here. Okay. Well, what happens is then it throws this open. I say that throws it open. Releases all tension, shuts everything down. Okay. That's how those were designed to work. I was also told a lot of traction engines did not get equipped with those, but a lot of stationary engines did, which kind of made me wonder why, which obviously you don't want a runaway engine or anything like that, but I know a lot of traction engineers, whenever they are operating on the road, your piston and your steam, that is how you control the engine. Forward, reverse, braking, it's part of the engine. So whenever this thing is not at full speed, this again, why this is under full tension, it holds the valve fully open. Okay, so you're actually controlling that steam with your throttle, your manual throttle that you're on, to control how much steam through your throttle valve it's actually getting. Now, when you're at full throttle, full steam, throttle valve's wide open, that's when this comes into play and will actually adjust your steam to stay at that set RPM that you want it at. Okay, so that was just a couple features that were optional on these. This one should be good to go. I'm happy with it. She does show a little bit of wear. I'm happy with how the valve looks. We do got some wear on this shaft here, but it's all been cleaned up. I know that it's going to get oil. Same with all this. This was all gunked up in here. I know that now when we oil it, it's going to get proper oil. And I'm kind of excited to get it back on the engine and see how it does this spring. Another thing a lot of people don't know about, and I've had to do some reading on to see how they work, especially this one, not a lot of manuals on these, are these hydrostatic lubricators. So typically on a traction engine, you had two options. A mechanical lubricator, which is what everybody likes. It's what we like. It's honestly what we run all the time. We've never had this one operational before. It will only operate whenever the engine is running, and it injects steam before your throttle valve. I say steam, injects oil into your steam before the throttle valve, and then the steam line will carry oil into your valve chest and piston and all that. From what we've gathered, our engine was used commercially to build roads, ran a threshing crew. They may have wanted this thing as just a backup or an extra source of oil while they were running it. So ours was equipped with this. Now, Brad Kelly out on the East Coast has given us our original build sheets for this engine. This is not mentioned. It has been added later. But I wanted to make it operational, make it functional. So, of course, I went through, replaced a lot of the fittings, Schedule 80 pipe, Schedule 80 fitting, Not really happy with the stainless steel Schedule 80, but it'll work. It's all McMaster-Carr had. I basically measured all the old stuff and replaced it with the exact same length. New glass, new gaskets, all that stuff. Was missing the drain valve. There's a parts lubricator up there. It's another Detroit. Had the exact valve that this should have had, so that's what I used. I repacked all the valves. But anyways, this was just a backup. It was another way to get oil to the engine. And basically, this is actually a Detroit Zero, was the model on it, specifically made for outdoor use, for traction engines or portable engines that were used outdoors. They don't have, and this is actually a good example, the condenser up top, which this is what it is. Obviously, this has wood handles, which would have rotted outdoors. This has two, and I've got the other pieces down here for it. It had two sight glasses, one to measure your drip rate for your oil, and two to kind of see just how much your oil and water level was, so that way you knew you never ran out. That would have been more for an indoor use with the wooden handles and everything. The Detroit Zero, I did find an old ad, was specifically made for traction engines. It was more vibration resistant. There's no wood handles on it to rot away. The sight glass is shorter on these to prevent breakage, and it only has one sight glass on it, so you have to really keep an eye on it. And how these work, these are plumbed in, so you've got your steam feed up here, your oil you fill up here, and then I've got more plumbing over here for it. There's your other kind of your steam shutoff valve right there that actually connects and feeds into this. Once you do that, you open a second steam feed valve, which is this little guy on this side, okay? And it's got a passage that runs all the way down. It's got a tube that runs all the way down to the bottom. And as that steam comes in and it condenses back into water, and you fill it full of oil, as it condenses back into water, it slowly raises that water level, which oil floats on water, okay? And then it comes over here, all right? So now you're pushing oil into this valve, okay? You adjust your flow rate for your oil. It's supposed to be so many drips a minute, and it actually floats up. You will watch it float up, okay? Your condensate, your water, it'll float up through that. All right, that's just a drain valve. This is just another on-off valve for the top in case your glass breaks. You can shut off either end. But then your oil comes up, it goes through here, and there's another passage. And this is all internal. This isn't just a wide open cavity right here. It's all internal. But there's another passage that will come down and goes through here. And this connects back into your main steam line right before your throttle valve. And it does the same thing as your mechanical lubricator. It dumps the oil there, feeds it into your engine. Now this will run whether you've got the engine running or not. As long as it has steam pressure to it, it will constantly run. So these are a little more high maintenance, takes a little more watching to keep an eye on them. Of course, you're going to have to keep an eye on your oil. As long as you've got oil, you're I say dripping, but it actually flows up. So you got to make sure that your oil stays good. Of course, when it's empty, when you're out of oil, this whole thing is full of water. You got to drain all your water out, okay? Then you fill it back full of oil, and then the cycle repeats. So this was a backup. Whether they just wanted extra oil in the engine, so you were running two lubricators, or they just wanted a backup, that's what this was for. We've never tried it. There's really no reason it shouldn't work, but big thing for me on our engine is making sure that everything it's equipped with is operational. A lot of people don't know how these work. I didn't know how these worked a few months ago till I started reading about them. It's a Detroit Zero, and these were designed, I found out, so not only were they less vibration resistant, rot resistant, because you don't have the wood handles, but how they operate is, since your hot tube basically goes straight to the bottom, it keeps your oil warm inside. No matter what, your oil will stay warm and flow. So if you're on a sawmill in December, you've still got good warm oil that's going to flow. So that was their big thing. I've only seen a couple of these Detroit Zeros. They're out there. I've seen a couple on eBay. I see this style much more often than I see this. So I keep an eye out for these. I think this is a 1-quart design. But I'm excited to get it put back on the engine and get it plumbed in just to say we have it. So maybe I'll get a video of what our engine looks like here shortly. So that way you guys know. I'll get a video with everything put back together on it. So appreciate you guys watching. I know that was a kind of a long video for what it was, but maybe you guys can understand a little bit how these work now. I've never been afraid to really dig in on these. A lot of this technology, while it can be dangerous from back in the day, this stuff is so simple. You know, I would have never guessed that a governor was as simple as it was. So I'd never be afraid to get back into another one, let alone this. I mean, there's really no moving parts on it at all. But anyways, appreciate you guys. Thanks for watching. Maybe you learned something. And go check my friends out at Chase and Rust. They said they gave me kind of a shout out on their last video. I was in their last video, and they've got some really good content out there. Go check them out. Thanks, guys.